we ripped out the pages. I'm recording. So now what we've been doing the last 4 days is graphing quadratics. We had 3 different ways, okay? We had standard form, where we had to do the negative b over 2a, and then we went to our table and got all the information. Then we learned vertex form, which was pull out the h and k, go to our table. And then yesterday it was in factored form, and we put it in our calculator and found the vertex because it was in the middle. And we'll review all 3 methods before test day. This is one more concept here, solving a quadratic by graphing, okay? So I'll talk about it more when I get to the next example, but the solution to a quadratic is the x values, wherever the graph hits the x-axis. So I'm going to show you the 3 different possibilities you could get, okay? So the first one would be if you had a quadratic that hits the x-axis in 2 places. Like, I don't know, any 2 places, it doesn't matter. We've seen all different types of quadratics. So like something, and I'm just totally making this graph up, okay? This is a quadratic that has 2 roots, is a new word, same as solutions, same as x values, same as x-intercepts. All of those words mean the same thing. Roots, x values, x-intercepts, solutions. So you might see roots, you might see intercepts, all interchangeable, okay? So don't let that bother you. The solutions are the x values. So x is -1 on my graph, and I'm just getting, it doesn't matter really how you graphed it, just wherever you hit the x-axis. So you could have 2 solutions, and that's because the graph touches the x-axis in 2 places, okay? That's one possible outcome. The second possible outcome is 1 solution, or 1 root, or 1 x-intercept, or what is the same word, okay? So 1 root would be if I hit the graph, I hit the x-axis just in 1 place, right? It's not hitting it twice. The solution here would be, on my graph, x equals -2. 1 solution hits the x-axis 1 time. So what do we think the third option would be? No solution. So what would that look like? Do we ever graph where the parabola doesn't hit the x-axis? Of course. How about this? You know it's going to keep going up forever. It doesn't hit the x-axis at all. So this is no solution, or you might see it say no real. Sorry, that says the word real. I squeezed it in. No real roots. And let me tell you what that means while you're writing that. What you've been working with up until Monday, coming up Monday, is something called real numbers. All the things you've done with equations and graphs and adding, subtracting, everything you've done, those are real numbers. There's a whole other number set called imaginary numbers, and we're going to start talking about them on Monday. So when your graph doesn't touch the x-axis, that means you have imaginary solutions, okay? And we'll go into that on Monday, but that's why you might hear no real roots. There are 2 solutions, they're just not real, they're imaginary, okay? But these are the 3 options you would get, okay? Touching the x-axis twice is 2 roots, touching the x-axis once, 1 root, not touching at all is no root. And then what is the root? It's whatever the x value is where you touch, okay? So let's see. So the very first beginning of your homework, I think 1 through 3, is just looking at a graph and saying that out, one of those. Oh, sorry. Solving quadratics by graphing. Let me give you guys a second to catch up. Maybe I went too fast, or am I? So we're going to be using all those skills that you guys learned over the last few days, which is really knowing about your calculator, okay? So let's take an example. Let's call this A. So what you might see it written as, look at this. They might just put equals 0 instead of putting like y equals. Here's why. Well, I'll come back to why. all of the problems that we're going to get are going to be in what we learned the very first day, which is standard form. Standard form. So what we're going to do is, I'm trying to think if I want to do it like that. Let's start out by finding the x value of your vertex. If you remember, it was x equals negative b over 2a. And this is the only math you have to do. Everything else is on the calculator. But remember, when it's written in this form, ax squared plus bx plus c, that's where you have to do one little math step before you go to your calculator. So b is 4, right? So I'm going to plug it in. Negative b over 2 times, what's our a value, guys? 1. Geo, come on. I get negative 4 over 2, which is negative 2. Remember what that is? That's the x value of your vertex. Now, to get the rest of it, let's go to the table, okay? So I would clear your RAM. My pre-calc kids are doing some crazy stuff. So second plus 712, second plus 712, clear your RAM. Go to y equals, and we've been typing these in all week, so this is no different than what we've been doing. So type in your equation. You don't have to put the 0 equals 0, just like we've been doing. Type it right in. No? Did you happen to notice in the last few days that it said anything about low battery? You didn't notice that? Is yours working? Okay, so where do I go next? The table. Yep, table. There's all the x and y values. I want to find out what the other value for my vertex is. So find your negative 2. It's negative 2, 0, right? So there's our vertex. Now, when we graph this, let's go ahead and just start with that. Let's put our vertex on there, and then we'll talk about it. So negative 2, 0 would be right here. Look at your table. Pick a couple numbers. Let's do like negative 1 and 0. Remember, nothing's different. Just you pick two numbers that are close to it. Get 1 and 4. Say it again.
So for example, 0, 1.
Okay, so I just grabbed those, graph them. Negative 1, 1, 0, 1, 2, 3, 4. Now, we know the AOS and this and blah, 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 and how to graph it. But this isn't a graphing problem necessarily. We're using graphing as a method. What is the solution to this? Yeah, negative 2. Remember, your root solutions are where your graph touches the x-axis. Where does our graph touch the x-axis? In one place. So this is just like the second example up above. It has one solution. Now, any point on the x-axis, you could write it as an ordered pair, right? I could write that as negative 2, 1. What number goes in that spot right there? 0, right? Every point on the x-axis has a y value of 0. So let's say you didn't, you could look and see on here. Anywhere you have a y value of 0, that is a solution. That's why they're sometimes called zeros. That's what these are called, roots, zeros. Because when y is 0, x is an intercept. Let's do another one, okay? So that's it. That's your solution. You're using the graph to answer the question, okay? Let's do another one. What if I give you this? Uh-oh. We're missing something. Or are we? Is it really missing? Think about it. You're missing the bx, right? So it's really like saying 0x. We just don't write it, right? If you don't have something, we just leave it out. But notice we have the x squared, so that's a is 1, b is 0, c is 4. So don't let that confuse you, okay? So x equals negative b over 2a. We have a negative 0. There's no such thing. But it doesn't even matter because if you have a 0, you could type that in your calculator. 0 divided by anything is going to be what? 0. So the first part of your vertex is 0. That's fine. Same idea. We go to our chart, find the rest of the information. So y equals, right? You can hit clear and then type it in. You can just type in x squared plus 4. Go to your table and find 0. Here it is, 0, 4. Pick a couple numbers. So this is really reviewing all of the things we've been doing this week. 1, about a 5, 2, 8. My eyes are bad. Now watch what happens here. Remember I said we want to know where y is 0. But when you sketch the graph, you're going to notice something that's going to keep you from having to look through the whole table looking for a y value. So 0, 4, 1, 2, 3, 4. My vertex is on the y-axis, right? When x is 0, that's a y-axis. So 1, 5, 2, 8, reflect. What? Did you understand how I got 0 here? Okay, so where's that point? Left or right, 0, up 4. I just graphed that point. Yeah? Guys, look at your graph. Where is the graph going to hit the x-axis? Nowhere. You guys know it's not good. Those arrows don't turn around and go back down. So we know by graphing it that this is no real roots. Okay? Because it's where does your graph touch the x-axis, Paris? Ain't nowhere touches the x-axis, right? Look, this is the x-axis, right? Not the y-axis, the x-axis. Okay? One more. Let's do one that has 2 solutions, so we have one of every example, and then I'll get you going on the homework and answer questions, okay? So last one. Oh, this is one solution. Say it again. Did you do the first example?
Yeah, I think the first one.
This was the solution right here.
So then my
Where it touches the x-axis. X is -2. That's the solution. X. Okay, I'll cover it with this one. Okay. All right. Yeah. Guys, I'll come around with graph paper for the homework. Okay. All right. Here we go. What's the first thing I do? What's the first thing, guys? Right? We have to do this when it's in this form. Be careful. Be careful. Look, I'm almost done talking, so guys, stay with me. Shh. When you plug a negative in where there's already negative, it changes to a positive. Right? 2 negatives become positive. Table. I see a lot of you not typing these in your calculators. That must mean you are very comfortable doing it and you're not going to need my help. Okay, and guys, remember, sometimes you have to scroll through your table to find the number you want. No.
Oh, I didn't type it in. Wait.
Okay, pick some numbers. Shh. Guys, you're being really rude. I'm going to use 2 and 3, which is, remember, any two numbers, either you could use 5 and 6 or 3 and 2 on either side of your x value. Same thing we've done all week. Took the numbers right out of the calculator. Let's sketch the graph and answer the question. I lied and said this was going to be 2 solutions. This is only 1 solution again. 1, 2, 3, 4, 0, right? Just plot that point. That's my vertex. 2 and 2, 3, 4. And 1, 2, 3, 1. So, here, just watch this part though. Okay, we are solving by graphing. We did the graph, and now the graph should tell us what the solution is. The solution is what? 4. And this is another one that just has 1 solution. Okay? So I'll make sure I do one in the homework. I'll do one in the homework that has 2 solutions, just so you can see it. Okay? So you graph it, and wherever your graph hits the x-axis is where what you're solving for. Okay? What the solution is. All right? So, guys, I'm going to pass out some graph paper. We are going to be, this is your homework. It's on page 145. I shortened it, 1 through 7. And this is A31. I'm going to pass out graph paper. And I'm going to do one for you. We can probably start in the first one. Okay, and these you don't need it. She's passing out the graph paper for me. So as she comes by, make sure you get one.
Yep.
Hey guys, shh. 1 through 3 are already graphed for you. You're just going to say, is it 1 solution, 2 solutions, or no solution? And what is it if there are? Okay? Everybody have graph paper that needed it? I think. You have extra. Just what you have. You guys good? Do you have graph paper, JJ?
Yeah.
Okay. Did I give you some?
Yeah.
Okay. Thank you, sweetie. Okay, so number 1, how many solutions? How many roots? How many solutions? None. None. No real. I like that better. Thank you. No real. But if you wrote no solution, I'd be okay with it today, but next week you're going to have to say something else. So you can say solutions, you can say roots, you can say x-intercepts. Roots is shorter, so I'm using that word. Okay? How many does number 2 have? 2. And what are they? That's when you would say x equals, that's this. So 5 and any order, doesn't matter. Okay? And this one, of course, has 1 solution. Is that -4? Yes, you're on fire today. Good job. Yeah. Okay, so now you're going to graph it, and number 4 I'll do with you. Okay, so you can use your graph paper. It is definitely easier if you use graph paper. So number 4, this is one that will have 2 solutions. I didn't have one in the notes for some reason. I don't know what happened there. Okay, so think about this. standard form, that means I start with this little baby formula. I have a joke for you, but it might be too soon. It might not make sense, so I might have to say it again another day. What do baby parabolas drink? Baby parabolas. Quadratic formula. Okay, so later we're going to solve using the quadratic formula. I'll tell the joke then. Maybe it'll be funny then. No, but you do win me over. Okay, so guys, when you plug a negative 10 in when there's a negative, remember it changes the sign. Okay, so that's a positive 10. Yes, the final answer is. Now that's not a solution. Remember what that is. That's just the x value of your vertex. So don't think that x equals 5 is a solution. Okay, that was just getting this number. Okay, then we go to our chart, our table. So y equals, clear, and type it in. Everybody should be typing, not just me. I know how to do this stuff. I'm really good at it, I promise. Vargas, you need to type this in your calculator. You're awesome. Okay, so table. What am I looking for in my table right now? 5. Do I sometimes have to use my arrow buttons? Yes, no big deal. 5, negative 3. What's your table? Is it a negative 3 or a negative 4?
4.
Is it 4? I'm sorry, I can't see. I said it was really good.
I'm so sorry. I don't know if I'm typing. I feel like I'm not pressing something.
You have, it's 21. You put 2.
Oh, I'm so sorry.
Okay, so pick 2 numbers. 6 and 7 are fine, right? Right there. Let's graph. One, 2, 3, 4, 5. 1, 2, 3, 4. There's my vertex. 6, negative 3, and 7, 0. Okay, so we clearly see we have how many solutions? 2. And we can name them just by whatever these are. That's a solution and that's a solution. So x equals 3, 4, 5, 6, 7. That's the answer. Okay? Guys, for the next one and for the rest of them, go ahead to change your table to count by 0.5s. So go to table set, and where it says change table, it says 1. That's what your calculator always does. So remember, what we're looking at when we do this is the table, right? So table set will change the table. It's above the word window. And we want to go to where it says change. That triangle means change in the table. Right now it's changing by 1s. So you just want to put 0.5 there. That's it. And then just go about your business. Go back in here and finish, okay? So I'm putting the key up here, but guys, I'm going to come around and make sure you're not just copying. You need to be doing the work. So the vertex, I just put in the chart. There.
Wow.
Remember, it's really dark. Sorry, this is that's the So guys, listen. A couple people have called me over and said, and they have the graph right, but it's hard to see where they hit the x-axis because, it's a curve and maybe it's like not perfect. But Bella reminded me, and you guys maybe, that anybody have one in there? If you use your table, you can tell what your x-intercepts are. What are my x-intercepts? Anything that has a 0 value of what? A y value of 0. So if you're not hitting exactly, like on this one, maybe you didn't graph it super nice, you should still be able to tell what those are by using your your table. Because anywhere y is 0, that is an x-intercept in a solution. Okay?
Absolutely right. Wow. Watch you grab it. This one. Watch this one more. That's why it's good. Why did you do that? You see? How did you get negative 1.5? That's the same thing as negative 1.5. Oh, that's negative 0.5. Never mind, I got it. It's the same thing I wrote.
So it's just 1/2. It's just negative 0.5, right? That's what I'm like.
Negative 1/2 and negative 0.5 are the same.
Oh, like.
No, wait, I.
And then so you have a 4.5. Okay, everything looks good. I think. Okay, this is what the one they were talking about. So you did everything right, guys. It's down here, but if you're right, you have some points down here. You know they have to go up somewhere and hit the x-axis. Where does that happen? Sometimes it's hard to tell.
That's what I was just about to say.
Look at your x-y chart. Find where
I was just about to ask that question.
you know it's going to
I forgot the plug. Sorry.
Okay. I don't know where you got that.
hard to be mad at it. Very hard to be mad at it.
Yes, yeah. Ding dong. Negative 1. Which is my negative 1 and 1? 0. Oh, see, I am. You know, no, you can do 1 too. You can do it. No! You very, oh my god. All my money. All my money. See, all my money. That's what I money. You don't have to. Yes, you do. You don't have to, but that's what we do. It's just making it harder on yourself. It's not like it's an easier number to grab. Do this. No, how about this? Why don't we just grab yours? Why do you see the graph? Same equation. You think it's probably no, but why are you going to make it harder? It's easier numbers to draw. I'm proud of you. I'm proud of you.
I'm proud of you. The headphones are on.
Well, then he'd be admitted to it. After you left. I was doing the exact same thing I did. I explained to him, he got it. A good amount. Same thing. You made a same thing. Exactly. You made a